Well, I visited Dr. Martin Smith to interview him for BLab codes. He also gave me a tour of the Kinghorn Cancer Centre. It's quite a magnificent place. Check it out. Any of those on the internet? Because I may have seen a few of them, yeah. Just exactly.
I think last week she released a new one with Vivid. So they had like a VISB, Visualization of Biological Data conference that was here at the Garvan. Well, it wasn't at the Garvan, it was in Sydney rather.
Right.
It's organised by Sean Gurley, who was at the Garvan. And she released a new video, I think. It was at Vivid as well. I don't know if they projected it anywhere.
Right.
Spent my evenings at home.
That's so cool. You'd never think that. Yeah, no, actually art and science are very much connected.
Oh, very much so.
Yeah.
And as Sean always says, like the way to represent data really helps interpret it as well.
Oh yeah, for sure.
Yeah, so each floor generally has like one theme. So there's like there's two immunology floors. Neuroscience is split on 2 floors as well, but the bottom floors I think are bone metabolism. Downstairs we've got a library with a bunch of journals and stuff.
Wow.
It's a really nice building.
It is very nice. This is the first time I've been in a research institute like this.
Oh really?
First time. Okay. Usually I hang out. At universities.
Oh yeah.
But so yeah, much different. This is actually really cool. Wow.
I'll take you to the lab.
Yeah, please.
My old lab actually.
Okay, cool. Hi. How are you going?
Looks like
Hi. How are you going? What's your name?
Nikki.
Nikki. How many?
Nikki's a PhD student.
Nice to meet you, Nikki. So you can do a PhD through this institute as well?
Oh yeah.
Ah.
So we're affiliated with University of New South Wales, but it's hard to get students. It's hard to get Australian students.
Why is that?
Because we don't really have like a foot in the door at UNSW. We get students that are interested in our research that will formally come and apply, but we don't like advertise and we don't teach there, so it's there's not that much communication going on.
Should do some lectures there or something.
Well, I tried. I gave a couple lectures there. And,
maybe hang up some flyers.
Yeah.
Yeah, you should go. Do you like research?
Cool. Nice meeting you. Oh wow.
Yeah, it's our research space. We've got some toys here.
So over here you do mainly molecular biology stuff?
It's mostly molecular biology, sequencing, generating next generation sequencing library preparations, playing around with yeast as well to do molecular experiments, a lot of genetics. That's about it really.
Okay, nice.
A lot of molecular cloning, this kind of stuff. It's really good. We've got all the facilities here. We've got liquid nitrogen, we've got -80 freezers, we've got mass spec machines, we've got there's an electron microscope downstairs. We've got all of this sequencing technology, all of latest toys and everything.
Okay, just a question regarding your students. So getting PhD students, and are you guys also offering positions for honours and masters, or is it just PhD?
No, honours, masters, everything.
Right. I've interviewed people before that have worked for the CSRO.
Yeah.
And one of the things they've told me is that...
Can we go down the stairs?
Sure, let's go down the stairs. That'll be probably better for the footage. But one of the things they've told me is that when they do work for... so they've worked for a CSRO, but a lot of that work remains confidential and patent. Is that the type of sort of approach that's also being utilized by the institute over here? Is that common in the industry, or is it...
It's common, but it's... I wouldn't say it's common. It's the end goal of a lot of this stuff is to get new treatments and new diagnostics and stuff, and a lot of those things have the potential to be commercializable, patentable. But generally, it's mostly academic research that's done here.
Okay.
We're generally trying to understand the causes and the mechanisms that underlie disease and normal health and this kind of thing.
Right. Okay. I see.
So there's nothing that's definitely in lockdown unless you're specifically working on a project.
I see. Okay.
You usually don't get students for that kind of stuff. You should hire an employee that will work on that.
Right. Because one of the concerns I think many students doing an honours or a master's maybe that they need to get publications out in order to get scholarships.
Strong pressure to publish here.
Oh yeah?
Oh, if you don't publish, you don't get grants. So.
Oh. Okay, that's awesome.
I'm lucky because a lot of the Garvan's funding comes from benefactors. So there's the Garvan Foundation, which seeks philanthropic donations to allow us to do cutting-edge research. because most of the time the kind of funding you get through grants and stuff is very conservative, and you know, the government will go out and fund a project that's a bit crazy, but has the potential to really revolutionize treatments or medicine or science. So we're lucky in the sense that we get a bit of donations and people here that specifically go to do this kind of promotion with the garden.
Right. Oh wow, that is beautiful. That is so cool.
Hoping that one day they'll put like a slide on the outside so you can just
slide on the backbone. Yeah, that'd be so cool.
We're lucky we have lots of really good speakers that come here. Every Monday at the Institute there's Leaders in Science and Society seminar, which is either great scientists or prime ministers or ex-prime ministers, these kind of people that really have a huge impact on science and society. So you learn a lot through that kind of exposure.
Wow. And this is a weekly thing that happens?
Every week, you know, sometimes there's exceptions, or sometimes it's not on Mondays, but generally every week there's a speaker.
Wow.
Like just on Monday we had just the head of the cancer division here, which is actually rare to have people from inside the government give these presentations, but it was really, really great.
Nice.
You're sitting here, you feel quite important.
Yeah, it feels like a TED stage. Oh, nice.
Facility to do single-cell sequencing mostly. It's called the Government-wide Centre for Cellular Genomics.
Right.
This is a brand new floor. So we've got a whole bunch of new robotics equipment, lots of single-cell flow cytometer machines. Got a room just for preparing libraries and troubleshooting protocols and machinery. Got a 3D printer in here. A whole lot of equipment that I actually have no idea what it does. In here we've got some sequencing equipment. This is more of the benchtop stuff. So there's got the Oxford nanopore sequencers, and the MiSeq and NextSeq and Illumina sequencers, and some more robotics down there. This machine, I'm told, is also one of 2 in the world.
What does it do?
It's a flow cytometer that can read up to 50 different channels, so 50 different colors, and it can split the cells accordingly. So it's really high resolution tagging of cells and separating the cells according to the molecular tags.
Wow, so 50. We have a portable one that can read about 4, but this takes it to the next level.
Yeah, I don't know what the other one is, but it's only 2 in the world. This is where I work. So I'm bioinformatics, so I work at the computer most of the time. In fact, most of us work at the computer most of the time. It takes a day or so to generate data that will last, you know, weeks of analysis afterwards. So.
Right.
It's my colleague James.
Hello, James. How are you going?
My desk?
Oh, you have like a standing desk.
Yeah, all the desks are all these new electronic standing desks. Really
Oh, nice. It's probably good for your back.
Apparently.
Yeah. Well, I've heard that sitting is like the new type of smoking.
That's right.
So.
Now, you want to sit down?
Sure.
I can show you the rest of the Kinghorn later.
Yeah.
It's pretty trippy building actually. Just look at it and get a taste of it. Just zigzagging staircases and these offices that just hang out in the middle of nowhere.
Well, the architects were very creative with this building.
Yeah, I hope the engineers were too. The stairs get really shaky. Makes for great sunsets. Often around, you know, dusk, everybody just comes to here like, wow, wow, and everybody goes rushing into this room and stare at the sunset over the city.
Nice.
It's pretty fabulous.
Yeah.
This new office.
It's a nice view as well. Huh. Very nice. Cool. Shall we start the
So big, and that machine, which is still not really available yet to the general public or to even to us, you can pump up so much data to your laptop or your PC, and then what happens is this one that's finished. You have this little kind of microfluidics flow cell. You open this up, you load your sample in, and then here there's the membrane that has all the nanopores on it, and that is connected to something like this in the back, application-specific integrated circuit, which measures the current in each of the 512 protein nanopores, and then the fluid gets, goes off into the waste reservoir. Load your sample, you close that, you go here. It's not set up yet, but you basically just press 2 buttons, click, click, and you're done. You sequence.
Wow.
And it blows up. It goes like the first few hours you get hundreds of thousands, if not like 500,000 reads. And they're full length, so you get the full length of the molecule. You can do RNA, you can do DNA, picks up epigenetic modifications like DNA methylation. It's absolutely fantastic for a lot of different applications.
Wow. Who was the genius that came up with that?
I think it was a couple of people, but you can Google it. Oxford Nanopore Technologies is the company. They've got the benchtop version, they've got that version, they're having the smartphone version that comes out soon. It's been really popular with people in like environmental sciences, looking at like metagenomics and soil and environmental stuff, because you can take it with you in the field. You can take it to the Arctic, you can take it to the space station, they've sequenced in space with it. You take it in a submarine, you can take it everywhere.
Yeah, it's so small.
So small. And it packs a punch. It's small, but you get, you can get almost a whole genome out of it.
Wow. Genome 1.
So Genome 1 was a spin-off of the Kinghorn Centre for Clinical Genomics, where they had a pipeline set up that could do really good whole genome analysis, and they incorporated it with clinical data and everything to provide a service. We can't really see it. Sorry, the blinds are down.
Oh, the blinds.
Oh, yeah.
If we could compare the price of sequencing to, let's say, 30 years ago, 20 years ago, how much has it changed?
It was $1 billion. More than $1 billion. I think it was $1 billion by the first human drafting the human genome. And now it's 1,500 Australian. Just to generate data. But,
wow.
Yeah, it's orders of magnitude. It's was it Moore's law?
Yep.
It's broken Moore's law.
Wow. And you could imagine, like, in 20, 30 years, it's going to be even more cheaper.
In 5 years, I think it's going to be a lot cheaper. Yeah. Who knows what the next big technology is? This Oxford Nanopore stuff is really, right now, just really blowing stuff up. Yeah, the competitors are getting angry. Lawsuits are being filed.
That's how you know it's a good disruptive technology,
Yeah.
It's people good. Are getting angry about it.
Exactly. It's good for the researchers. It's probably not good for the stakeholders.
No.
The shareholders.
That's right. Cool. Thank you so much, Marlon. I appreciate the tour and your time for the podcast.